Hi, welcome to Trip to Mars, coding a robot rover in the classroom, featuring the PascoBot, especially the PascoBot Sense and Control Kit. I'm Dan Burns. I'm the physics curriculum and training developer here at Pasco. I've never been to Mars, but I did used to be an aerospace engineer, and I worked on Mars programs during my career, including transportation ideas for getting a rover to Mars. Closest I ever got to Mars was flying in the stratosphere on NASA's Sophia 747, but that's not very close. But what I'm hoping is your students get a lot closer, and one thing to help them is to inspire and prepare them for careers in STEM, and something like the PascoBot is going to be able to do that very well. We are doing a Zoom webinar, and so your camera and microphone are muted, but please feel free to communicate with each other in the chat. There's also a Q&A tool, and use that to send questions to us. And so my team is standing by to answer your questions and take your comments. If you put them in the Q&A, it queues up for us, and we can tell if we've answered them or not. We're going to be recording this, and it'll be posted on Pasco, and I don't know if we're sending the link out or not, but you'll definitely be able to find it if you have to leave us early. Don't want to spend a lot of time on slides because, hey, I've got two PascoBots here. We want to show you what they can do, but this is what the PascoBot Sense and Control Kit is. It is a robot with a brain that we call the control node. It runs off Blockly software that is integral to our SparkView and Pasco Capstone software packages. One thing that really makes it unique is there are a lot of devices collecting data, and you can see that data displayed live on your device as the PascoBot is operating. We'll definitely see that. The control node also has a built-in accelerometer, 3-axis accelerometer, and a speaker. And then in the Sense and Control Kit, there are 3 main accessories: a rangefinder and a line follower, which attached to the PascoBot, and then a gripper that gets plugged into the servo ports. It also has a rechargeable battery that just goes on and on, as far as my testing shows anyway, and it connects to your device with Bluetooth, and you can run code off your device, or as we'll see, you can upload it directly to the control node, and then it'll work independent of your device. That's real helpful if you're going to go off to Mars, which is too far away for your computer to communicate. I've been working on the PascoBot activities, and so I'm going to highlight those as we show how to use the PascoBot, how to code it, and what all these things do, and hopefully it'll spark a lot of ideas in you to come up with for uses for the PascoBot. The activities increase in skill level as you go, and so we recommend people do them in order. 3 of them only use the PascoBot, not the accessories, and if you were to do those 3, you'll think of tons more on your own. They are all available free and are downloadable right now on pasco.com. Just search PascoBot. I think there's some links being put into the chat that will get you there directly as well. There's a teacher guide for each activity, and the format for the activities is a research, prototype, test, improve, which gives the students early success. They'll see things happening, and then as challenges come, you can modify them based on the coding skills of your students. We also give sample working code in the activities so you can differentiate the instruction. Maybe you have some super coders in your class and some who are new to it, and so you can decide whether they get to see the sample code or not because, well, the activities are in Word format. But let's move on to the PascoBot. As I mentioned, it runs off SparkView or Pasco Capstone. I'm going to be using SparkView. And let's say we just got this thing out of the box and we want to use it. Now I have the gripper attached to this just to make things go more efficiently in our webinar today. But let's just assume all we have is the PascoBot, no accessories attached to it. I want to do something. Well, we want to make it move, right? And so first I need to connect it to SparkView in my device. So I'm going to turn it on. And I see a red flashing button on the top that tells me the Bluetooth connection is ready. And there are different paths I can take to connect to it. Either sensor data or build new experiment would be the thing to do with the PascoBot. Let's do sensor data. And that looks for Bluetooth devices in the area, and it found one. And that is the one I want. I can tell because of the 6-digit ID matches the one shown on the top of the PascoBot on the control node that's in it. So I just click on that to connect. And then I need to make a decision about what data I want to display, and I do that by checking it or unchecking these boxes. And notice all the different things you could display. In this case, I'm going to put position and velocity. We'll see some of the other ones later as we go. I notice the rangefinder distance is showing up because I have the rangefinder connected here. And there's also the servo current tells me that I've got the gripper connected. So let's just click graph, but nothing's going to happen yet. We need to code this. So this is the display window. The code window is a toggle here. If I click on that, I go to the code window. Click again, I go back to the display. Oh, I just remembered another thing I want to do. I'm going to change the data collection rates to 50 hertz. That helps with something later. The default's 20 hertz. And so this is our code space. And these are all the Blockly menus that are color-coded, which makes it real easy for students to know where to go for certain blocks. Another thing that makes it easy is the Pasco code library, which has functions loaded in it that you can download for use with the PascoBot and other sense and control kits. And that's up here. And so if I mouse over that, it says import code from the Pasco library. And I click on it, and it knows I've got a PascoBot connected. And if I scroll down, I'll see there's a lot of choices. I'm going to pick that first one, move a distance. So now you can see some blocks that populated our code space here. This is the actual function, and it's collapsed. If I do a right click, I can expand it and see the whole code. So more advanced users that want to really get down into the guts of what's happening here can do that. And we'll talk a little bit more about the stepper block, which is the heart of the PascoBot functions. But let's collapse it back, and really all you want to do is drag that off to the side, make sure you don't delete it. This block calls that function, so that's the one I'm going to use in my programs. And there's a code, a comment note block. I'm just going to delete it, but it does tell me that if I put in a negative number for move a distance, it'll go backwards. So I don't want it to go backwards, so let's put in a positive number. And let's just see what happens if I click start. Well, it moved, and it went 85 centimeters. If you were to measure that, it goes really precisely 85 centimeters. But now I have to go all the way back here and get it again. What if we can have it come back to us? So how do I do that? I can go to the functions here and bring another move a distance function out. Or I can do a right click and duplicate that one. That's a little better because it also duplicated the math block that I want. And so since negative is backwards, that should bring it back and forth. But instead of watching the code window, let's go see what it looks like in the display window. You can see what we got last time. Let's create another display. And notice this is going to happen live as the PascoBot is performing the code. So now it goes 85 and it stops and comes back. Pretty smooth motion. You can see a little bit of a dip there as it turned around, but it's executing our command very precisely. A very nice distance graph here. And you can do all the analysis functions that you use SparkView for with our smart cart and other sensors. For example, what if I were to take the slope of this line here? And so I select that line, toggle to the selection tool, and I want the slope when I was moving pretty steady here. And I can just click on that, and it says the slope is 0.34, and that would be meters per second. Well, that looks about what the velocity is here. We can double check that with the coordinate tool. And what do you know? 0.344. So they can do a lot of the kinematics. They can, as we say at Pasco, we were learning to code, but we're coding to learn. And so you can learn physics and math as well. A little more advanced, what if I were to get the area of this part of the graph? That's in the statistics. So the area is 0.845. Well, how far did I go? 0.8 something. And so I can put a coordinate tool up there as well. And it says 0.85. So the area under that curve is the distance. Lots more you could do with this, but let's go back to the bot. That's what we want to show off here. Well, we've got it so it's going back and forth. It'd be better if we could get it to go and navigate a maze, or you could do some vector activities as well. To do that, we need to make it turn. So let's go back to the code window, and there's a function for turning. And it's actually two functions, turn left or right. So I import those. Again, these are the functions themselves I'm dragging out of the way. Let's magnify those a little bit. I can see them, but just barely, so it's got to be harder for you. There we go. And if you wanted to see what those look like, you can always expand them, and you can see the stepper block in there with some other things that help it turn. In this case, right angles, left or right, depending on which one you do. So I'm going to have it go in a counterclockwise rectangle. So when it gets here, it's going to turn, well, better turn left, or else it goes off. And so I can, these are, again, the things that call it. So I can have it turn left and then go not negative, but positive 35. I worked this out ahead of time, so hopefully it doesn't go off. That turn right block, I'm not going to need it, so I'm just going to delete it. But I can always get another one back here in the functions. So once I import it from the library, they populate the function menu. Well, we're going to need some more turn left ones. Another option is I can duplicate the block. And as we saw before, that's helpful because it comes with the math block there. And then we need another left turn and another 35. So that completes the rectangle, but let's have them face the same way he started. They started before we went. And here we go. Fingers crossed. Yes. Is it going to go off? I measured right. So I'm pretty restricted with the table here, but imagine in a classroom all the things you could be having it do in a maze, navigating around the classroom, and then, boy, looking at the gripper, you can think of other things it's going to do as well. Let's go back to our graphs. Now, if this was a Mars rover, it's good that we can program its motions because Mars is very far away, so that it takes minutes for our commands to reach a rover on Mars, and then minutes for it to tell Earth what happened. And so you can't drive in real time controlling a rover from Earth that's on Mars. It'd be like if I configured your car so that the brake would work at 10 minutes after you pressed it. That'd be very difficult. You'd drive really slow, wouldn't you? But wouldn't it be good if we also had senses so the rover could make some decisions on its own? And one of them is using the built-in accelerometer. It can tell when it encounters rough terrain or an obstacle or a steep incline. And let's just demonstrate that. I'll go back here and let's just have it move a distance. And then let's make another page. And so at the beginning, I selected the data inputs I wanted to display, but that's not a permanent decision. I can always display the other ones. And so I made a page. Let's make a graph. And if I click the y-axis, I can see all those same choices available. And I'm going to pick the x acceleration, which is the acceleration in the direction of motion. And if I put an obstacle in front of it, let's see if we can tell when it hits it. And so you can tell. So you can have the code monitoring the x acceleration and then make decisions based on what it gets from that. For example, one of the activities, it would then back up and go around. Maybe it just stops. It's up to the students what they want to have it do to navigate around the obstacle. Now, another thing it does is it can determine whether it's going uphill or downhill. I'll show you that. I'll just tip it. And so you can see uphill and downhill. So you can use that information to tell it, well, maybe at a certain level you want it to turn around. It's too steep. Or maybe you need it to slow down. And then maybe downhill, maybe it can speed up. And so that's another activity the students use to navigate hills, potentially on Mars. So that's something the rover can do on its own as long as you program those capabilities ahead of time, but it's using its own senses. Well, you can take another sense, which is the rangefinder, which I have installed in this one. The rangefinder sends out a pulse of infrared light and can actually measure the time it takes it to reflect off an object and come back. And so it can measure things out to about 1 meter away and then really close, a few centimeters away. And so this is sort of giving the rover sight. And so it can detect an obstacle and then take an action before it bumps into it, which would maybe be a better idea. So let's look at the final code for this activity. In this one, the students explore the rangefinder, incorporate it into their code. And the final thing is to try and have it so it uses the rangefinder to navigate around obstacles, or if it bumped into one, sometimes it bumps in on the side, it's going to take action based on the accelerometer input. So it's a little fancier code, but it'll give you an idea of what you will see. So here's the code. So this time we're using not move with a distance function, it's the move with velocity. And so for that one, you have to tell it to keep moving. So that's why I have this repeat while true loop on. It'll just keep going until I hit stop. You could put some other conditions in there. One we like is when you tip it up like that, it'll automatically stop. And so it's going to move and it's monitoring the distance to objects. And if it gets within a certain value, I think I put, what did I put here? It's going to it's going to randomly turn right or left if it gets within 0.2 meters or 20 centimeters. And then it also has a if conditional that will tell it to turn a random direction based on the accelerometer input. So let's see what it does. Oh, turn. And I can. So I don't want it to go off, so I'll get in its way. As you can see, it randomly turns direction. That can help it get out of corners and things. And let's have it, I'll knock it. So that now I'm using the acceleration to make it turn. Let's see, one more time. So you get the idea. Imagine having a fleet of these cruising your classroom, not only avoiding obstacles on the floor, but each other. That would be the kind of classroom I would love to be teaching in. Not so fun on the table, but still pretty fun. That's a fairly advanced code there. Let's go and look at the line follower. So the line follower installs in the same place that the rangefinder does. So we can only have one of those two devices installed. So this one has the line follower, which is 4 separate infrared emitters and detectors, and they're pointing down, and so they're measuring the intensity of light coming off the surface they're moving over. And then you can take action based on what that intensity is. So let's open up an activity. And I need to connect to this one. So this one has an ID code of 715. So now I can go up to the Bluetooth menu, and I'm going to disconnect the other one. I don't want it to go flying off the table here in response to something I'm doing. And I pick the other one. There we are. And I have the line intensities being measured, displayed here as 4 graphs. You really only need one to do what I'm going to do here. Is you have to calibrate the line follower for your surface and the tape you're using. It comes with white and black tape, and that'll pretty much make it work on any color surface you want, but you need to calibrate it first. So if we look at the code, we don't want this code to run at the moment. So up here in the left, I can disable execution, which is handy to have. You just have to remember it's up there. That's one of my most common mistakes is I forget I disabled code execution and then it's not running. I'm like, what is going on? So it's in red, pretty easy to see. And so now it's just we're gonna get data from the intensity measurements here. So I hit start, and I'm just going to push it across. One time works well, but just to give you the idea, there's 4. So I want to know the line intensity and then the surface intensity. So again, all the SparkView tools work. I'll use the multi-coordinate one so we could show all those would work. It looks like the line is 90. 91, you could average those, really just doesn't have to be that precise. And then the surface is around 15. So let's say 90 and 15. So now I go back to the code window, and here's the line follower function that I got it already from the Pascal code library, follow line there, so I already got that. And let's enable it. And line intensity 90. So I put this in earlier. Notice they're different. That's because we now have the studio lights on. So it made it a little different. I think those values would have worked, but that's fine. Now I want to upload this to run on the control node itself. And there are 2 reasons I want to do that. It runs faster if it's already downloaded on the control node, and if you have a really challenging line course, this one isn't too challenging, you want it to be able to react quickly. And so it works running off the computer. It works a lot better loaded. Also, I can write a second code that runs off my computer that will tell the code that's uploaded here to execute and stop executing. And that opens up a whole world of possibilities. As I'll give you a little bit of a introduction to that anyway. But to upload the code to the control node, I don't want this. So I put a note around it, and I can disable that, and so now it won't upload. And I can go up here. The upload is right here. I should hear a little beep. And I can now run it. I can hit the power button on the bottom once and it'll start running. I can run a code that'll start it running, or I can hit the execute button up here. And so it follows the line pretty well, but the line ends. It's going to go off the table. We don't want that to happen. Whoop. It's not that one. You got to hit stop up here. So now I'm going to disable this code. It's already uploaded, so I don't need it now. And normally I'd start writing code, but I already have it written here. And so we enable this. So this is going to start running that uploaded code. And then it's going to run a loop, and it's monitoring the total intensity. And so I created a variable that adds all 4 intensities together. And if they're less than a certain threshold, then it's going to tell the Pascobot to stop. Now, the surface was about 15, and this is all 4 sensors, so the surface is going to be about 60. So I probably should change this. 60 worked before. I need something a little higher than that. 100 should easily work. 80 probably work, but I want to make sure. So now when I run off the computer, it's going to start the line follower, and then when it gets to the end here and doesn't detect a line, it should stop. Oh, so what did I tell you before? Code execution disabled. There we go. If you make a mistake enough times, then you remember. And so now it stops. Well, that's not so interesting. It's good when you get it to work, but then it brings up a lot of possibilities. I can have it, instead of stopping, turn right and go and do something. So this is kind of like rovers at an inhabited Mars base, and they're helping the astronauts because it's dangerous outside. They don't want to go out and get supplies. They want their rovers to do it. So they could lay a path down for the rovers to go to their different storage facilities, to get rid of waste and everything else. And maybe there are different tasks you need it to do. So you can also do things like, what if there was a piece of tape that was in front of all 4 sensors? That's going to show differently, and you can have the code do something different. Or you could make the tape wider, and that's going to show up as a different signal, and you can have a different action. It turns right when there's 3 here, it turns left when there's 2, stops when there's a line, and so all kinds of different things, and that's part of the activity for the line follower. Well, let's get our gripper back here. And I have another gripper activity to show. And I'm going to need to connect to the Pascobot with the gripper and disconnect from the other. So we don't want that one now. So with the gripper, there's also functions that you bring in that can raise, lower, open, and close the gripper using the servo motors. and there are functions that use that. And the students learn how those functions work and practice picking up and delivering objects. And it culminates with this activity where we wanted to collect these cups. And again, this isn't so exciting on the table because I don't have that much room, but it should be good. And so I'm not using the rangefinder, which I could, to help the PascoBot find the cups, but I wanted to have an activity where all you have is the gripper because it is sold separately. And so this is going to be the PascoBot doing this blind, which is a little tougher. The line follower can also help it find cups or other things. Just as we saw, it could, when there's 3 pieces here, it knows to grab a cup, and when there's 2, it knows to deliver the cup, and etc. And I think we're ready to go here. So what it's going to, well, let's see what it does. I think I have enough space, barely. So it's going to keep doing that to all the cups. The different variables are the spacing and how the PascoBot moves. Just back and forth makes it a little easier. But I'm also monitoring the servo currents. And when it's holding a cup, the servo currents is higher than when it's not holding a cup. So, for example, somebody moved a cup, it tries again, and again. Oh, let's give it one so it's happy. Oh. And so I have it giving up after 3 tries. So the goal is to get all 5, but the final part of the activity is to improve it by adding a way to monitor the servo current to have it give some more tries. So students have been exposed to the rangefinder and the line follower. When they see this, the obvious thing is, how can we incorporate that to make this even work better? What more complex tasks can we do? Can we stack cups? The main problem you're going to have is students are not going to want to leave your classroom when the bell rings if you're engaging them in activities with the PascoBot. Just wanted to show one more thing here. So I have this saved so I can just put it in the trash. And let's just bring out, just wanted to show for more advanced users, the stepper motor block, which is powering the wheels here. So how does that work? Well, you can have it so the stepper rotates continuously or through a predetermined angle. So I'm going to do that, and there are 2 steppers. And so I'm going to have the one in port A, which students can find out which that is just by trial and error. I'm going to have it go through 2 revolutions, a max speed of revolutions per second, and acceleration of 2. What gives it the direction is the sign on the speed. So technically, I guess that's a velocity. The angle and the acceleration, you're just telling it the magnitude. And then 2 and 2. And so you might expect it to go somewhere here. Let's see what happens. Well, it sort of went somewhere. It went in the circle. And that's because when it's going, one of the stepper motors is turning clockwise and the other one's turning counterclockwise. And so students discover that and realize, hey, if I want it to go somewhere, I need one of them to have a negative. There we go. So that just gives you a little taste of what is in the heart of those other functions, and more advanced students could create those functions using the stepper motor block. Well, thanks for joining us here today. I hope you're excited about the PascoBot Sense and Control Kit, and we'll investigate it at pasco.com. Just search PascoBot and you can find out a lot more about it. Thanks for joining us here today.